In this video, we will talk about arc length and surface area for polar curves. Okay, so the first thing that we'll talk about is arc length. So we were given this formula. This formula, you can kind of easily derive it using parametric equations. So just use the parametric equation formula and then just let x equals r cosine theta and r sine theta. So what I really want to do is just do a couple of problems. So here, find the length of the polar curve, r equals -4 sine theta, and theta is between 0 to pi. So here, notice that this is just going to be a circle that's hinged on the negative y-axis. So what you want to do is, look at this restriction. It's not going to be from 0 to pi. It's not going to be from 0 to 2 pi, because from 0 to pi, you already have the full complete circle if you've done it before. So we're just not going to go ahead and just use the formula. So the first thing that we want to look at is dr over d theta. That's going to be -4 cosine of theta. Okay, and now let's plug it into the formula. So L equals the integral from 0 to pi of the square root of r. R in this case is this -4 sine of theta squared plus this -4 cosine of theta squared, d theta. So 0 to pi, you're going to get the square root of 16 sine squared theta plus 16 cosine squared theta, d theta. We know that that's just going to give me 1. So the integral from 0 to pi, square root of 4. Oh, that's wrong. Square root of 16. Because sine squared theta plus cosine squared theta equals 1. So you have the integral from 0 to pi of 4 d theta. It's going to be 4 theta from 0 to pi, which gives me 4 pi. Okay, so there really is nothing much to these problems. Now, not all problems are going to be this easy because it really just depends on what r is going to be. So let's do one where it's a little bit more involved and you actually have to use some identities. So let's say we want to find the length of the following. So let's say r is equal to 2 plus 2 cosine theta, and theta is from 0 to 2 pi. Okay, so this one's going to be a little bit more involved, and you have to tap into the identities. So we're going to start off with L. So we're going to start off with dr over d theta, because we're going to take the derivative. So that's just going to be equal to, that's going to go to 0, so a -2 sine of theta. So now let's go ahead and plug it into L. So L equals the integral from 0 to 2 pi. And then we're going to have the square root of r squared plus dr over d theta squared, d theta. I don't know why I wrote it, but okay, let's just go ahead and plug it in. So we're going to have the integral from 0 to 2 pi of the square root of 2 plus 2 cosine theta squared plus -2 sine theta squared d theta. So this is going to give me 0 to 2 pi of the square root of 4 plus 8 cosine theta plus 4 cosine squared theta plus 4 sine squared theta, d theta. So you can go ahead and use this identity again, the Pythagorean identity. So you just are left with 4 plus 8 cosine theta, and then the other one you're just left with a 4. So then you have a 4 and a 4 that just collects it, and you just get the square root of 8 plus 8 cosine theta, d theta. Okay, this looks a little better. Let me take out an 8. So you're going to have the square root of 8. So square root of 8. And then square root of 1 plus cosine theta. So basically I just factored out an 8, took out the 8, and I left the 1 plus cosine theta in there. So the square root of 8, what I can do, take the square root of 8 out, and I have the integral from 0 to 2 pi of the square root of 1 plus cosine theta d theta. Now here's where you want to be, I don't know, you have to do a lot of different things. There's many different ways you can do it. One way is to kind of use an identity. Here's what I'm going to do. I'm going to go ahead and just take this square root of 8, integral 0 to 2 pi. So here what we have is this square root of 1 plus cosine theta. Now, typically what you might want to be able to do is you can use an identity, but I think what I'm going to do is multiply kind of by the conjugate, because there really is nothing that I can really do here. Oh, that should be a minus. Okay, there isn't much that I can do. I can do an identity, but that can be a little bit tricky. But I'm going to just multiply by the conjugate, okay, and see what that gives me. So square root of 8, integral from 0 to 2 pi. And then in the middle, you're gonna have 1 plus cosine of theta, 1 minus cosine of theta, divided by the square root of 1 minus cosine of theta, d theta. Now, alternatively, what you could have done is use the fact that you have this identity. So the fact that you have cosine of 2 theta is equal to 1, oops, that's wrong, equal to 2 cosine squared theta minus 1, and then rearrange this so that you can get this. That's always a little bit confusing, so I think that this might be a little bit better. I'm not sure. So square root of 8, integral from 0 to 2 pi. So the top part, if I reduce everything and I FOIL it, you're going to get 1 minus cosine squared theta, divided by the square root of 1 minus cosine theta, d theta. So now notice that 1 minus cosine squared theta is just going to be equal to the integral from 0 to 2 pi. That's just equal to sine squared theta, divided by the square root of 1 minus cosine theta, d theta. Okay? Here's where the tricky part comes in, because when you take the square root out, you're going to get the absolute value of sine of theta over square root of 1 minus cosine of theta, d theta. So you have to be very careful, because the sign actually is negative in certain parts. So if you think about it, all students take calculus, the sign is negative in quadrant 3 and quadrant 2. So one way to kind of think about it is, because we know that this guy's symmetrical, okay, our beginning, I forgot what it was, our beginning part is symmetrical, okay, one thing that we can do is just do it from 0 to pi and then multiply the whole thing by 2. So 2 square root of 8 integral from 0 to pi, and then change this to a regular sign so that we can only take the positive side. And then all we got to do is just do u substitution. So I can let u equal 1 minus cosine of theta. du is equal to, what is this? Negative sign, which is a negative to positive sine of theta d theta. Okay. So this is going to be equal to 2 square root of 8 integral from 0 to pi. This is for thetas. And then on the top, you're just going to have 1 over square root of u du. So if I do this, you're going to have 2 square root of 8. Let me change this to, that's just going to give me times 2 square root of whatever u was, which was 1 minus cosine of theta. And this is going to be from 0 to pi. So you're going to be left with 2, oh, that's going to be 4. 4 square root of 8, then times square root of 1 minus cosine of pi, minus square root of 1 minus cosine of 0. So you're going to have 4 square root of 8. This is going to give me a negative 1, which is going to give me a positive 2. This is going to give me a 1, which is going to give me a 0. So what I'm left with is 4 times square root of 16, which is going to give me 4 times 4, which gives me 16. Okay, so that was such a long problem, but it involved a lot of tricky integration. Okay, so it really just depends on what the function kind of looks like, the length. Okay, so the last thing that we will do is surface area. Okay, we have two different types of formulas. So basically, you want to take this polar curve. So I really cannot draw this, but if you have a polar curve that kind of looks like a circle, let's just say we have a circle, and you want to maybe rotate it around, well, what you're going to end up getting is kind of like, oh God, here I go. You're going to end up kind of like with the, kind of like a donut. Okay, so if you kind of think about, have some sort of, I don't know, a little bit of perspective, you can kind of see that if I rotate this circle, you're going to just have this little donut thing that you have. So this is kind of what rotating it about this axis will do. And same thing about the y-axis. Now, a couple things. When we talk about x-axis, we're talking about the polar axis. So if you remember that in polar world, this is the polar axis, and this guy is just theta equals pi over 2, because that's where pi over 2 radians is at. Okay, so we have two different formulas, and then here ds is basically going to be the arc length associated with polar. So this is just a whole bunch of a big mess. It's honestly not even worth it. When you come to do problems like this, you might as well just use a computer at this point. So, but we'll just set up a couple integrals. So set up the integral that gives the surface area rotated about theta equals pi over 2. So here is my polar region, and here is my values. So nothing so much to it. Let's just go ahead and just plug it into the formula. Since we want theta equals pi over 2, it's just going to be equal to this guy. So it's going to be s is equal to the integral of 2 pi x ds. Okay, the first thing to kind of worry about is this ds thing. So ds is going to be equal to the square root of r squared plus dr over d theta whole quantity squared d theta. So let's figure out what that guy is going to be. So r squared is just going to be the cosine of squared theta whole quantity squared. The derivative of that, well, the derivative of dr over d theta, so if it was cosine squared, is going to be 2 cosine of theta times the derivative of that, which is going to be negative sine of theta. So this is going to be negative 2 cosine theta sine of theta squared d theta. So you're going to be left with the cosine of to the 4th power of theta plus 4 cosine squared theta sine squared theta d theta. Okay, so let's just leave that like that. And now what we want to do is plug it into our surface area formula. So we know that the surface area is going to be 2 pi x integral ds. Okay, so now all we have to do is plug in the theta values. So well, the theta values, which is going to be from negative pi over 6 to pi over 6, I think, right? That was what it was. Yeah, pi over 6. Then you have the 2 pi. We'll worry about the x in a little bit. And then the ds is just going to be the square root of this cosine to the 4th d theta plus 4 cosine squared theta sine squared theta d theta. Okay, now we have to think about what exactly is x. Okay, we know that x equals r cosine theta. We know what r is equal to. R is equal to cosine squared theta, and then you just have an extra cosine, which is going to give me cosine cubed theta. So this is going to give me the integral from negative pi over 6 to pi over 6 of 2 pi. And then x in this case is going to be equal to cosine cubed theta square root of cosine to the 4th theta plus 4 cosine squared theta sine squared theta d theta. I'm not even sure this can even be integrated, but since we just wanted to set up the integral, this will be the integral. So usually these are pretty horrific. I mean, you can always just use a calculator or some sort of technology to evaluate this if you really want to know what the answer was. But this is basically what the surface area formula would kind of look like.